Good afternoon, ladies and gentlemen. Welcome here at the Technical Forum at the group exhibit Hydrogen Fuel Cells and Batteries, this year in 2015 at the Hanover Fairground. Here in the Technical Forum, we'll present to you interesting topics regarding the hydrogen industry. Every 15 minutes, you will hear a different speaker. Today's topic are off-grid applications, off-grid fuel cell applications. I'd also like to welcome our online guests. We have guests from all over the world right now. Maybe it's even afternoon there or night or morning. We are live streaming from the fair. My next speaker will talk about methanol fuel cells. He'll talk about the past, the present, also the future of the methanol fuel cells by Serenergy. And for that, please welcome with me on stage CEO of Serenergy, Mr. Korsgaard. Big hands, please.
Hello, everyone. Welcome to my presentation here about methanol fuel cells we produce at Serenergy. Here we go. So first a short introduction to who we are. We are located in the northern part of Denmark. Where the company was founded by myself and my colleague here, Mads Bang. Last year we were acquired by the German industry group Fischer Group. It's located in the southern part of Germany, a tier 1 and tier 2 automotive supplier in terms of stainless steel tubing and related products. In Denmark, we do the systems and solutions manufacturing. We do all the sales and marketing, service and support in connection with that. And also, of course, the R&D efforts we have on the methanol fuel cell side of things. At Fischer Group Solutions, which is another daughter company of the Fischer Group, they do the development of the production machinery and processes related to it, and also, of course, large-scale manufacturing of the key components in our products. Serenergy is located in Aalborg, as I said before. We were established in 2006. At the moment, we are about 45 employees, 55 including the personnel at Fischer working with fuel cells. Privately owned, founded by myself and Mads Bang. Fischer Group is a global supplier, represented in 12 different countries around the world. It was founded in 1969 by Hans Fischer there. The staff of about 2,000 employees, growing quite a lot in particular in China and Mexico at the moment. So, what do we do? Basically, we have a fuel cell which can be regarded as a portable battery charger or a diesel generator sort of thing. So we basically put in a fuel, which in our case is a methanol water mix, and out comes electricity, and the power coming out there is controlled, so it can do battery charging or constant power or whatever the customer require. Our key value proposition is 50% fuel savings, typical compared to a diesel genset, depending on the region of the world. It has a 40 to 50% electrical efficiency from methanol going in to electric power going out, so that's including all parasitic losses. And this is state of the art in the world in a non-hydrogen system. There's no harmful emissions, as everything is happening below the temperatures where they occur, and such as NOx and SOx and so on. And of course, there's more or less silent, except for a little blower that's integrated for cooling purposes. The smallest product we have in the line is a 350 watt, which has been on the market for 5 years now, I think. It has an output of 24 volt DC, weight of 13 kilos, so it's quite portable, and a fuel consumption of about 440 milliliters per hour. About 4 years ago, we started, 4 or 5 years ago, we started the development of the 5 kilowatt unit, which has the efficiency. Really, we reached the target of 50% on the system level, but subtracting the system components, we are about 45. The weight is 70 kilos, including radiator, cooling circuit, power electronics, controls, everything, including the the fuel pump to actually take up the fuel from an outside tank. It's a 19-inch rack mountable, so we often use it as building blocks to create larger systems, and as I'll show you in a little bit, it's 700 millimeters long and 6 rack units high, so that's 253 millimeters. We offer it in different output voltages from 48 over 250, 350 and 750 volt now, so it's a configurable product. So it can be integrated both in telco applications all over the vehicle spectrum to AC power delivery. I'll come back to that as well. It has a startup consumption which we managed to reduce quite a lot the last year from about 3 kilowatt hours of electric energy, or 2.5. We managed to get it down to 0.2, which is in this regard more or less insignificant. We have a preheating time of about 30 minutes, which is sufficient for hybrid configurations with battery packs of above, let's say, 60 to 100 amp hour on a 84 volt level. Ambient temperature can range from 0 to 50. We also have means to go sub-zero and even a little bit higher than 50 as well, climatically speaking. The H3 rack is sort of a solution, customized solution we built for some customers. It is offered in a 2.5 and a 5 and a 10 kilowatt solution. So the 10 kilowatt, of course, involves 2 modules here. We can also replace one of the modules here with a lead acid battery pack or lithium-ion battery pack. So it's a complete hybrid system, including the fuel tank here in the bottom. There's also on the side here, you can see in our booth, we have mounted different filters and dry contacts and so on. So everything is really, it's a drop-off solution where we actually also can monitor the unit via 3D connection wherever it is in the world. So, so the markets we address, some pictures here to give you an impression. We have a diesel genset over there in the corner, smoky one of the kind. Where we have this drop-in solution I showed before. This one over here is with a hybrid configuration. As you can see here, there's a battery pack here of a 48 volt. But we also do a lot of works in the electric vehicles, not only passenger cars, but actually more on industrial vehicles, including buses, forklifts, and other commercial vehicles. We also have APU, which is sort of in between for maritime purposes. We have a big project here in Germany with Meyer Werft on cruise line ships. So a range of markets there. Some examples of what we have been doing. This is a telco deployment in North America, where we had a dual 350 watt setup. With the 72 hours of autonomy given by these methanol fuel canisters. As you see, it's very easy to scale the capacity of this system as it's a liquid fuel. We are working with anything from these 20 liters up to thousands of liters, IBCs. You know, it's very scalable concept. We also have integrated some of our. This was also a 350 watt deployment into a forklift truck that's doing field trials at the moment, in a combination with a lead acid battery pack. Actually, the previous lead acid battery pack here was just replaced by a combination of a smaller lead acid battery pack and the fuel cell itself. So again, it acts like just another battery, but with a much longer runtime and the ability to instant refueling. Here's also one of the things we are exhibiting here at the show. As you can see, it's a 19-inch rack with 6 modules in, so it's a total of about 30 kilowatt peak load. They output about 350 to 400 volt DC, which is applicable for input, for instance, for a solar converter that can be on or off grid, so operating in island or on grid mode. There's also 50 to 60 kilowatt output on the thermal side to provide input energy for absorption cooling, for instance, or for heating, or for steam generation, or whatever. A little bit more on the technical side, we're working with the high temperature PEM fuel cell technology. So our operating temperature is 160, and that's the whole trick about what we're doing. This is why we get the efficiency. This is why we get the compactness when working with methanol. We have tried more or less all different kinds of fossil fuels. We work with anything from natural gas or diesel and gasoline and LPG and even jet fuel and JP8 for the military purposes. But it's clear that if you want to have a competitive system with a low kilowatt-hour cost per produced or low cost per produced kilowatt-hour, methanol is the way to go for multiple reasons. One is the efficiency and the capex of the product, which is the lowest obtainable, but also the cost of the fuel itself is also very low. The fuel cell operates with a CO tolerance of up to 2%. So where other people have to, or the low temperature technology, you have to insert a cleanup system to deal with the CO. We don't have to have any gas cleanup, so we can go directly from the reformer to the fuel cell. Startup time, as I mentioned before, on our product line currently is 30 minutes, but the stack itself we managed to start up in only 5 minutes, provided that there's enough thermal energy. There's no water generation or humidification needed, so that's also a big advantage. Inside the module, we actually have it exhibited over there as well. We have the fuel cell. And basically what happens here is we take methanol in, we evaporate it, we convert it into hydrogen, passing it through the stack, and the remaining part, the last 15% of the hydrogen gas is becoming too thin, basically. So we have to, so we use that for heating the reformer. So this is a complete process integration we have there, and this is why we are able to obtain these 45% efficiency. If you compare to other technologies, the red curve here is the efficiency curve of the 5 kilowatt module. A typical diesel generator peaks in this range of about 80% of full load, where we are actually peaking our efficiency curve at part load. And as most applications, they don't run at 100% of full load all the time. Usually, actually, they operate at less than 50%. We have a really high benefit of this high efficiency at part load. If you compare to the typical efficiencies on the low temperature application side, which is the green curve here, you have the problem of water vaporization. You have the gas cleanup, which causes a lot of parasitic energy consumption. So this is why we are able to lift the curve here into the 40s. I should also say that the efficiency curve drawn here is net efficiency. So it includes the loss for the system components. A few words on methanol as a fuel. In the places where we operate, we actually are quite well represented in developing countries. And in these areas, methanol per energy unit is actually cheaper than diesel and gasoline. Of course, then there comes some distribution cost on top of this. But it has the highest production efficiency of any synthetic fuel available. That means that compared to hydrogen, biodiesel, or ethanol, we are achieving, or we are not, but the industry is achieving like 71% efficiency from, for instance, natural gas to methanol. And this is also the reason why it's that well priced. It's compatible with all fossil fuel resources today and also renewable energy sources in the future. There's also no new energy infrastructure needed, as it's a liquid fuel. Basically, what you need to do is line the tanks or the transportation media with a polyethylene liner or whatever, and then you are able to use the existing energy infrastructure. If you look at how the consumption of methanol is going today, we see a rapid growth here on the use for energy purposes, and this is in particular China, who's leading the way here by blends of methanol into gasoline on a relatively large scale. Today, there's annual methanol production consumption of about 69 million tons, compared to the annual gasoline consumption, which is 880 million tons. So we're looking at about almost 10% equivalent to the annual gasoline consumption. So it's a fuel that's widely available, is available throughout the world. It needs to be distributed the last way to the customer side. But it's something where we don't have to talk about the hen and the egg. It's something that's available. If we look at the big picture, which we like to do sometimes, if we are represented in the vehicle up here, which could also, of course, also be a stationary application, where we have a hybrid system consisting of the fuel cell and the battery, and of course the methanol tank here. In Denmark, where we come from, we have a very high penetration, actually sometimes way above 100% of our electricity comes from windmills, so we are dealing with fluctuation in renewable energy on an everyday level. What the discussion is a lot about today is, of course, how to get that into electric vehicles, and that's also a perfectly sensible way, in particular if you want to even out night and day production. But if you want to store energy on a weekly, or monthly, or seasonal basis, you have to go to a much more to a cheaper energy storage. And this is where we suggest to use methanol as an energy storage, because it's already available. We can pump into the existing infrastructure. There's new setup needed. But how do we get from windmill energy, windmill or solar energy to methanol? That's what happens over here, where we basically have the usual electrolysis hydrogen vision. But instead of pressurizing it, we suggest to combine it with carbon as sort of a natural way of storing energy. And this carbon can come from a plurality of sources. It could be CO2 capture from a power plant. It could be gasification. It could be biomass. It could be a lot of different sources, even air sequestration, some suggestion. So basically, by combining hydrogen and carbon dioxide in the right mix, you can synthesize this gas into liquid methanol. Today, the waste majority of methanol is coming as a byproduct of the oil industry. So that's flare gas. So instead of burning off gas, you basically convert it into methanol. So already today, it's a waste product from an industrial production. So with this vision, you are able to take a step by step. So the methanol doesn't need to come into a fuel cell car. They can go into a traditional car. So you are able to take baby steps. You don't need to make a revolution, but you can take it step by step. And this is what we believe in is the best pathway to sort of enable that we are competitive with existing technologies out there in the market. To work with electric vehicle as a part of the vision, because that's going to be there. And also the batteries, I'm sure, because there's no more efficient way than to pump electricity directly from the grid into the car. But the question is, do you really need a 60 or 80 kilowatt hour battery for going 400 kilometers? No, is our answer. You can combine it with a liquid fuel that's basically, as some person told me today, it's basically a liquid electricity. This is what methanol is. It's liquid electricity. So, summing up here, this is what we are doing on the vehicle side. This is a Fiat 500 we are exhibiting here in the booth. It was converted by a Swedish company to electric drive. We put a tank in. We put a 5 kilowatt module. Connected to the battery pack that the Swedish company installed. It consumes, gives a range of about, it has a consumption of 11 kilowatt hours, and so battery pack. So the fuel cell range is about 450 kilometers on the methanol and additional 100 kilometers on the battery. The fueling infrastructure is developed together with the biggest fuel supplier in Denmark, which is OK Gasoline, and Hamag did the filling station development. This system will be deployed in our hometown, Aalborg, in August, where we're going to put up a few cars as well and I think it's going to be the 27th or 28th, and we are going to make a World Methanol Day for starting up this activity. Okay, thank you.
Thank you also from my side. And now we do have time for a few questions, and I'm sure there will be questions from the audience. So this is the time where you can ask your questions.
Hello, thank you for your good presentation. And how long is the lifetime of these fuel cells?
Depending on how many start-stops you have. So it's like a diesel genset, but it's let's say roughly speaking, it's 5,000 hours, up to 7 if it's a continuous operation, and 4,000 if there's a lot of start-stop cycles. So similar to an internal combustion engine in a car.
Thank you very much. Is there any opportunity of bringing this particular product as a permanent solution for telecom cell site?
Yes, there's.
Number one. Number two, in a country like India, where availability of grid power is less than 18 hours out of 24 hours, how do you see this product flying?
Sorry?
How do you see this product becoming relevant there?
So definitely India and in general the developing countries and the telco sector is something we are looking very much at, and that's of course also why I'm showing the 48-volt solution here, which is basically a drop-in power solution for either supplemental power for the telco industry or even continuous 24/7 operation. So this is definitely one of our key markets that we're looking at today.
Thank you. For further questions, you can approach Mr. Korsgaard at booth number E71. Once again, big hands please for our speaker from Serenergy. We will have a short break here in the technical forum, about 10 minutes time, and then at 2:40 we'll have our next presentation. Our next presentation here at the Technical Forum will be about off-grid energy solutions based on direct methanol fuel cells, and for that we'll hear the head of customer service at FSC Energy, Mr. Kai Stegmann. So please welcome, I will welcome you back in about 20 minutes time. You can also relax here and have a coffee. The drinks are all on the house, and there's a lovely lady walking around to serve you drinks.